All right, so we're going to focus on vertical asymptotes now. We're going to suppose that f of x, of course, is a rational function that has been reduced, which means that p of x and q of x have no common factors. All right, so that's an important thing. Then if some x location, x equals a, is a 0 of the denominator, then we would say that the line x equals a is a vertical asymptote. So we've got to remember the graph never crosses a vertical asymptote. It can't because it simply doesn't exist there. And then we also know that one or more of the following is true. This is more of our arrow notation. That our function, our f of x, is either going to infinity or negative infinity as our x value approaches that a value, either from the negative side, which is what this means here, or from the positive side. So this is a little bit easier to understand with some pictures. So let's go look at some pictures. So we want to write these in arrow notation. So here, remember, we're looking, this is saying we're kind of writing on this graph, and as x gets closer and closer to 3, so as x approaches 3, and we're coming in from the negative side, f of x is going up, up, up to positive infinity. And you can put it in the opposite order. It doesn't really matter here. Okay. This one, kind of pretty much the same story. As x approaches 3 from the negative side, our function is approaching our y values. We're going to negative infinity. So that's kind of what looks, a couple of options for our asymptotes. Here we're at a different location. This time we are approaching negative 3, but this time we're coming from the positive side, and our function, of course, is going up. So f of x is going to positive infinity. And then, of course, our last one, as we come in, as x approaches negative 3 from the positive side, f of x is going down to negative infinity. So that's our arrow notation for each of, these are the only 4 possibilities, really, that we have for vertical asymptotes. The only things that would change, of course, are the x values that the vertical asymptote is located at. All right. So how do we find these vertical asymptotes? Well, we're going to find the domain of the function, and generally to do that it'll be easiest to factor the numerator and the denominator. Of course, the denominator is really our most important part. There we go. Any factors in the denominator that do not cancel will result in vertical asymptotes at those particular zeros. Any factors in the denominator that do cancel will give holes where the function just simply doesn't exist. So for example, here there's no factoring to do, so nothing cancels, right? Our domain is going to be what? We got to have x can't be negative 10, right? Because our factor in the denominator, x plus 10, we don't want that to equal 0. So we would have x can't equal negative 10. So we'd write that negative infinity to negative 10 union negative 10 to infinity. Great. Now, y-intercept. This one is pretty simple. So when x is equal to 0, y is going to equal 4 over 0 plus 10. So 4 over 10 or 2 over 5. We don't really care there. Our related function here is, so when we think about how we're going to graph this, our related function is just 1 over x. And so we see from what we remember about transformations that we are shifting to the left 10 units. That's the 1 over x plus 10 part. And we also have a vertical stretch by a factor of 4. And that gives us the 4 over 10, x plus 10. Okay, so we haven't drawn anything yet, but we can draw something now because we want to know what the vertical asymptote is. This x plus 10 doesn't factor, so we have a vertical asymptote at x equals negative 10. So we're going to draw that in here. And what do we know? We know, first off, that our 1 over x, our graph of 1 over x, should look roughly like this, right? And so when we sketch this thing, we know it's going to be looking like this. And I'm not taking into account here our vertical stretch. We could do a plug and chug here, but I'm not going to. So what's happening as we get close, but that does help us with the next question, which is what happens as we get close to x equals negative 10. And the answer is, well, it depends on which side you're coming from, right? So as x approaches negative 10 from the positive side, that would be this side, our f of x goes to positive infinity. And as x approaches negative 10 from the negative side, our f of x is going to negative infinity. So there we go. And that's a good place to stop. We've got several more examples for you, though.